We are going to take area bounded between x equals 2y plus 6, or x plus 2y equals 6, x equals 0, y equals 1, revolve around y equals negative 2. What makes today different is this is not the x-axis or the y-axis. This is y equals negative 2. So this will cost you points on the test. This is definitely where it starts to get a little bit more challenging. I hope that yesterday's lesson with the washer and the worksheet, things worked out pretty well for you. There is a slight mistake on problem number 7. If you want to cross out number 7, that's fine. If you want to do it, that's fine. But there's a slight mistake with problem number 7. So, yep. So anyway, but we're going to take this curve. It's actually just a line. But x plus 2y equals 6. Can somebody tell me what the x-intercept is for that line? Very good, it's 6. How about the y-intercept? 3. I'm also bounding this by x equals 0, which is what? Y-axis, and I'm bounding this by y is equal to 1, which is just a horizontal line, right? You see the area that's bounded here. If you were to try to find the area of that shape, would you draw vertical rectangles or horizontal rectangles? Either actually works, right? But since we're going to revolve it around y equals negative 2, we're going to revolve it vertically. Let's do vertical rectangles, okay? So I'm just going to draw my first vertical rectangle right there. But now what I have to do is, instead of revolving it around the axis of x equals or y equals 0, I revolve it around y equals negative 2. I'm going to go down 1, 2. So this is the axis right here that I'm going to revolve it around. So I'll make this a black rectangle I'm going to revolve around. Now try to get this picture. A lot of times before, you guys would say, well, you know, this is 1 unit up, so I'll just move it 1 unit down. No. How far is the bottom of this triangle from the axis of rotation? 3 units. So I have to go down another 3 units for the bottom of that triangle. How many units is the top of the triangle from the axis of rotation? 5. So I have to go down a total of 5 units for that. And you have this coordinate over here. So hopefully you could draw that reflection appropriately. But well, same thing. You know, this point, it's going to be located in x value of 4. It's just going to be 3 units below the axis of rotation. So I'm going to rotate this around. This is the inside, which is really beautiful. And that's my washer. I want to be clear that the visualization of this is you know, really paramount to your ability to perform the problem well. But sometimes people have an easier time with it than others. Just like, you know, some people have an easier time reading maps than others. It's okay if that's a struggle for you. Just do your best with it. So here's where things get a little bit different. Okay, I'm going to draw this washer off to the side. Again, to me, the mathematics that we're doing now looks just totally sweet. You know, it involves all of the, you know, type of mathematics that we've done over the course of our years here in high school. What is the width of this washer? Dx. What is the axis of rotation? What makes up this center? Y equals negative 2. What makes up the inside of the washer? y equals 1. What makes up the top of the washer? X plus 2y is 6. Now, if this is all y equals stuff and it's dx, this has to be written in terms of x, right? So I should solve for x. So I have y is equal to negative 1fx plus 3. So far, everything looks pretty good, but here's where you get that slight change. I have to look at the radius on the inside. And normally you would look at that and you'd say, well, the radius is 1. Well, think about it. What's the distance between 1 and negative 2? 3. So what we learn that if you want to find that height of that radius, you need to do top minus bottom. That's going to determine height for you. Everybody agreed? So when you look at the big radius, what's the top function? Negative 1fx plus 3. What's the bottom function? Negative 2. So we're going to subtract negative 2. And we get negative 1fx plus 5. And that's our big, well, that's not all real numbers. That's equal to my big radius. So top minus bottom will determine that. That's a little bit different, right? Okay with that? All right, let's then write an expression for the volume of one of these shapes. Pi times big R squared, or negative 1/2 x plus 5, that quantity squared, minus, what's little r? Squared is 9, dx. How many do we want? An infinite number. So we set up an integral times pi. We'll square this out. Negative 1/2 x squared. 1/4 x squared. Negative 5/2 x and negative 5/2 x. Negative 5x. 5 squared minus 9. Bounds. A lot of people get concerned about the bounds. You always have to look at your original area. This is where you drew your first rectangle, and it's that you're going to use for the rotation to create your washer. So that's where we determine our bounds. Since it's dx, we have to consider the x value of our bounds. Where do we start? 0. Where do we end? y4. Why do they intersect there? You have this coordinate right here. So Darren sees that the height of this right here is a y value of 1. So when you plug 1 into the function, you get x plus 2 is 6. So that makes this coordinate 4. So therefore, the x value is 4. Now, sometimes in the AP test, they'll give you that coordinate, or they'll give you the shape ahead of time, so you don't have to try to draw it. But we want to try to push ourselves so we can be prepared for anything. So there we go. Time to just integrate. No big deal. Pi times, what's the antiderivative of 1/4 x squared? X cubed over 12. 5x squared over 2 plus 16x evaluated, 0 and 4. Pi times, plug in 4. 4 to the third. 64 over 12. Divide each by 4, we get 16 thirds. 4 squared. 16. Divide by 2. 8 times 5. 40. And then 16 times 4 is 64. So we've got 24 multiplied by 3 is 72. So pi times 16 over 3 plus 72 over 3 is 88 pi over 3. That's sweet. I mean, you understand what all that means. Whereas at the beginning of the year, if we would have shown you that right away, you would have wondered what a lot of that is, right? It's pretty cool. Pretty cool. Good work. One more. You're going to have I'm going to give you an assignment today, and you're going to have all day tomorrow to work on. You have no lesson. Full day to just work. Nothing else. On the very back of your notes, write down this. We're going to find the volume of the area formed by y equals 2 minus x, y equals 0, and x equals 0. And we're going to rotate it around x equals 3. Very back page, write a new spot. So you should have a blank sheet of paper on the very back of your notes. I should have built this in, and I forgot to. Because I'm a putz. I'm lazy. So y equals 2 minus x. What does it look like? Line with a slope of -1. Y equals 0 is the x-axis. X equals 0 is the y-axis. Everybody agree I have that triangle? I'm rotating around what? X equals 3. Well, what does that look like? A vertical line, right? We're not rotating around the y-axis now. We're rotating around a vertical axis that's different. X equals 3. Well, if I kind of mirror this image on the other side, it looks like I can go all the way over to 6. We're going to draw that. Could you draw vertical rectangles and find the area of this first shape? Yeah, but I'm going to draw horizontal because I'm rotating it horizontally. Whoop. You need to draw the washer so you represent the original shape. I drew the lines on the opposite side. That's not our original shape. My bad. Originally, I put these vertical lines over on the right side. I don't want to do that because our original shape is on the left side. Okay. What makes up the outside of the washer? It's x equals 0, right? And then the inside of the washer is your y equals 2 minus x. What's the thickness? The y-line. Go get some brain food. We'll polish that off and call her good. All right, let's finish this off. You guys did a good job modeling this problem. We need an inside radius and an outside radius. And I've lost my marker, which is awesome. Oh, thank you. So I'm going to look at the larger radius first. So if I go from the inside, the rotation, to the outside, what is that distance? 3. That's big R. Now, what I want you to understand is that you took 3 minus 0, correct? Think about it. If this was 3 and the outside was -2, what would the radius be? 5. So when you go horizontally like this, the way that you find that distance of that length is, instead of taking top minus bottom, you do the right minus the left. My smart board got dumb. Well, see, this inside here is x equals 3, and the outside is x equals 0. So that means that's a distance of 3. Well, we'll do little r in a second. So you do right minus left in order to get that distance. So now we'll do little r, which is going to be that right there, right? Just this length, right? Yep. So what's the right side of that? 3 minus this thing, right? 2 minus x. But it needs to be in terms of y, doesn't it? So if we add the x over subtract the y, we get x equals 2 minus y. So 3 minus 2 minus y is what we have there. If I distribute the negative, I end up with y plus 1, right? Y'all good with that? Now, if you want to check it, just pick some points, okay? What's this coordinate right there? 0, 2, okay? What is the radius right here? It's 3, isn't it? Y plus 1. See it? What's this coordinate right here? 1, 1, right? What's the radius? It's 2. Y plus 1. See? So sometimes, you look at your radius in order to try to confirm that your drawing is accurate. So we've got this. We've got the integral times pi of big R squared. What's big R? Square root is 9 minus little r squared. Little r squared is y plus 1. Quantity squared dy. I'm going to look at my original shape in order to determine my bounds. Am I looking at x values or y values? Y values. So I go up to 2. Good. So we got pi times, we've got, I'll just still do the integral. We're going to have 9 minus y squared minus 2y minus 1 dy. dy then, 0 to 2. And we'll just combine some pieces here. So we've got pi times the integral from 0 to 2 of, going to have an 8 minus y squared minus 2y dy. Sweet. Antiderivative. 8y. Plug in 2, we get 8/3 plus 4. Whoop. That was a plus sign. It should have been a minus sign, right? There we go. My bad. It's minus 4. So we get 12 minus 8 thirds, or 36 thirds minus 8 thirds, 28 pi over 3. So this is an extension of the washer method that we saw yesterday. The difference is we're rotating around an axis other than X or Y axis. You have to keep in mind that you need to do your right minus your left. Okay? So we've seen area, we've seen discs, we've seen washers. We have one more, and that's cylindrical shells, which we'll do on Monday. Tomorrow you have a full work day on this assignment. I will let you know tomorrow. Right now, I'm thinking about possibly trying to stay away from the test next week and going to the following week because of your senior dinner dance and the Wall of Inspiration and stuff. I'm just worried that, yeah, we're not going to have time. Okay. Yes.